So my background is in physics. Originally, actually, I did astrophysics in my bachelor and master's. And then for my PhD, I switched to this quantum biology. And at first, I worked on how birds can see magnetic fields. Then when I finished my PhD, I started working on photosynthesis in small algae. I led an Oceania team because I'm based in Australia at the moment. Yeah, so we worked on this photosynthesis project, which I'm also normally working on. And yeah, those are like small algae which live underwater. And the problem then is that a lot of the sunlight gets filtered out by the water on top of them. So they have to be very efficient at doing the photosynthesis. And to do that, they have built a big antenna complex around the protein, which actually converts the energy from the exciton to the chemical energy which the plant can use. But then the next problem is that the light hits this antenna complex somewhere, and now the energy has to be transported very efficiently to this protein which uses it. Yeah, we worked on simulating how this exciton transport happens. Originally, we had more team members, I think 6 or 7, but actually like the most qualified people, some PhDs which were working in quantum biology, like on the one hand, I think they had imposter syndrome, like I don't know how much I can contribute. And on the other hand, like they were both PhD students, they got swamped last minutes by their supervisors with their own project. So then they couldn't participate. So now we had a really interdisciplinary team. Yeah, we had one theoretical physicist, but normally he works in particle physics. He was amazing at setting up the theoretical model about how energy got transported. Then we had another physicist, but normally he works on quantum computers in solid states. So just crystals and everything is frozen, no biology. And he was good at calculating the structures using the methods which he had like in quantum computing to calculate how the models look like. And then the third member, she's a computer scientist. So yeah, no physics, no biology, but she helped building a pipeline basically because we needed to use different programs and had different output and something. And yeah, output from one needed to be fed into the other and so on. And she helped like integrating all of these programs. I was amazed at how the team members liked the topic. Like I thought like, okay, you're working for free on a weekend and so do you like it? But all of them were amazed by quantum biology because for them it was something completely new. And yeah, especially like James, our theoretical physicist, he was like constantly, oh, I'm blown away. This thing exists. This thing can happen and so on. Yeah, so I was blown away myself by their amazement on the topic. Some points, for example, to describe my project better, because it was a lot of people, both my team members and also later on the general public and the artists and so on, to describe my own project in simple terms and to visually describe it, because before I often hid more behind like the terminology and so on. And yeah, sometimes it's really hard to understand what does actually happen in this quantum physics things. And yeah, to describe it visually helped me a lot better to understand what's happening. I think the favorite part, like working with all of these people, like both with my team and also with the other team leaders and so on in person. It was really nice to just talk about the different projects and yeah, in my team to see something actually evolving out of it. I didn't expect that we would produce something in just 2 days, but yeah, it did work. So I think it helped a lot, again, that it was that interdisciplinary, that you had to understand what are you actually doing. And it helped a lot with solving problems. There were some problems which I had for quite some while about like how to model, for example, this energy transfer or something. And now a theoretical physicist had a completely different view on it. And yeah, I think for that reason it matters, and to make it more public for the general public. I guess it's longer term. Like, it's, if you want to, you can just hack 48 hours or something without stop. You don't, yeah, you don't stop, just the results are coming in. It was a bit complicated, like, because we're Team Australia and in different time zones. So most of the time, like, someone was always working at the project. But I think what helped more than like different scheduling was that the team was the interdisciplinary, because otherwise, like, as a researchers, we often have the freedom to work whenever we want, so we could work 2 days non-stop anytime. On the one hand, there were some kinds of calculations which didn't completely finish, so just calculating some energy levels. But as soon as they finished, I can actually test if this whole pipeline which we built works. So I would like to see that. And then in my project, I'm somehow working on several steps of the workflow at the same time. So actually, next week, I'm, for example, going to measure structures again with an electron microscope. It would be the very first steps, which just getting the best input or something, but that would help to basically get a better input at the end. And yeah, at the same point, with the very last part, I'm excited to see if it works, and if it works, to make it more complicated. Yeah, I loved it overall. Like, yeah, I actually even liked that it was short-term notice. Like, I'm not sure if others mentioned it, but yeah, it was maybe 3 weeks or a month before it happened. Like, Clarice told us all that it was happening, and then you still had to find a team and yeah, see how you get to Berlin and stuff. But yeah, I liked it. I liked that it was short notice because it was lower pressure. I think if it had been long in advance, maybe I would have put effort in to actually find the best team ever, or like most qualified people, or I wouldn't have participated because I wouldn't have thought that I would be qualified. But now it was, yeah, lower pressure. Like, if someone was interested, I took them into my team. And yeah, again, it was amazing. It was a really nice team which just loved working on the project. So the most important thing I want them to know is just that quantum biology exists at all. So that some quantum physics exists in biological systems. If then they are willing to learn even more, I would like them to know something related to my project, which is that in biology, sometimes like the chaos and having less structure is good, and also having warm systems. So systems where all of the atoms move constantly, that can be better to preserve these quantum mechanical effects. Contrary to what we physicists normally think, where we want to keep everything cold and stable and so on. No big open thoughts, but just like how I loved it overall. Like, both, like I liked the team, and I liked the meeting the team leaders in person in Germany. Yeah, talking with all of them, learning about their projects and so on.
That's amazing.
That was amazing. Oh, and thanks to Clarice and Pedro for organizing it. That was amazing.